join us in our panel. And I also warmly welcome Professor Dr. Felix Rey. He's the director of the Virology Department, Institut Pasteur, Paris. Thank you for joining us. Professor Rey, when you look back to your past 24 months, to the past 2 years, and when we talk about the lessons learned from COVID-19, and also maybe some blind spots when we also debate and discuss about being prepared for the next pandemic, what do you see?
I think it's very important. I mean, one of the lessons that we have from this pandemic is the fact of...
Take your microphone a little bit closer so I can...
it's the action, for instance, the knowledge that we had. So, for instance, we had a vaccine in a remarkable period of 10 months, which had never been achieved earlier. So this was a combination, as we know, of the messenger RNAs and the lipid, but also of the sequence of the molecule that we put in. So the spike glycoproteins with specific 2 proteins mutations that made this to be stable and to be the right immunogen. And we knew that because we had been other experiences like the SARS-1 coronaviruses back in 2003 and then the MERS, and people had been investigating on this. And which goes to show that when you know enough on a given viral family, on a given coronavirus, for instance, you can apply. But it so happens that for many other viruses that are around, we don't have that knowledge. And so one of the important things to know is that we know how many different viral families exist and for which we don't know enough. And so one of the lessons that I see is that we should really do not neglect viruses just because they're not causing diseases at a given time, but have like a broader research focus on trying to have at least one exemplary from each of the families that could emerge, and there are many examples like that. And I think this is one of the lessons that we should keep in mind and not go always running after an outbreak. We were lucky this time, despite the problems that we had in the pandemic.
Thank you. Professor Ciesek, would you say we were lucky with all the lessons that we were learning or that we are still learning?
Yes, I totally agree with you. And so for me, my personal lesson was that it's really important to work together in a crisis and not each for its own. And not only within one discipline, like we are all virologists, but also with different disciplines, but also with policy, with the politics, and with the industry we have to work together, because when I think back 2 years, the universities had the cell culture systems for SARS-CoV-2, and the industries had the compound libraries to screen for antiviral drugs, and then they had to work together and can develop faster antiviral drugs, which was really nice, but there's still an improvement, I think, because when I think back, then when industry and university have to work together, you always need a contract because it has to be fair for both sides. And that was the problem when I remember back, because this takes weeks or even months to have these contracts ready. And I think this is what we can do better the next time, that these contracts are ready before we have a next pandemic and before we can start, that we can directly start and working together.
Professor Mettenleiter, when you think back, what gives you a smile and what gives you a headache?
I see a smile, or you see a smile, certainly I can agree with the development of vaccines. This was really a blueprint, and this is something where I really think we learned a lot for preparation for the next pandemic, which I'm sure will come. I think, all the experts will agree. The other side of the coin definitely is that this intersectoral collaboration, didn't work as well as it could. And I sometimes say this SARS-CoV-2 pandemic was a huge field trial for the real one. And the real one could be something that we virologists could think could be much worse. We heard about case fatality rates today already. I mean, the average case fatality rate that SARS-CoV-2 induces, I mean, is not really exceptional for a pathogenic virus. So I think, I mean, what we need to learn is exactly this intersectoral cooperation. What we need to learn is to use all the competences and capacities that are available. And there is still a lot of room for improvement. OneHealth is nice, I mean, but it needs to be lived. It needs to be put on the ground, and this is what we have to work on very quickly, because, I mean, as I said, monkeypox is already, I mean, showing us that our preparedness is probably not as good as it should be.
We will talk about the OneHealth approach in a minute. Let's skip that for a second, and let's ask, from your perspective, and we talked a lot about, I mean, we don't have the future class, you know, in front of us, but from your science, do you expect to have more zoonoses very soon coming up in all of our daily lives in future? And of course, how free or unfree do you see our everyday lives from zoonoses? When we think, not just, you know, for the next upcoming 5 years, but also let's think in times of decades or 10 to 20 years. Can you give us an example from your science?
I mean, zoonotic infections are a natural phenomenon. This is biology. This is nothing special. As I said, I mean, man is part of the animal kingdom, and so, I mean, viruses that jump over species barriers between animals, they also jump species barriers towards humans. So we will never be able to really completely reduce the spillover events. But I think what we actually will see is, with the increase in human populations, this is just, I mean, a numbers game. The more humans are on the world, I mean, the more likely they get in touch with animals. Animals both in the terms of wildlife, because we intrude into habitats that we didn't do so before. There is, I mean, change in land use. There's deforestation, for example, that plays a role. But there is also a situation that more people need more food. They also want to have more food, I mean, animal protein, which means we have more livestock. Livestock needs to be fed. There needs to be more feed for them as well. And this is kind of a vicious circle that we need to break. Because otherwise, indeed, we are, just by the numbers, we are entering in a period where these spillover events will happen more frequently, and they will probably and also more frequently develop in something like starting with local epidemics, then some of them expanding into pandemics. On the other hand, I think we are also a lot better in, at least in technology-wise, in discovering these spillover events and being able to discover the first development of infectious chains. And this is something that I still firmly believe in, that we can get significantly better in detection of these early infectious chains, in syndromic surveillance. And I think this should be a focus working on that. But as I said, if we really want to prevent, we have to drastically change the way we live.
The way we live. We also talked and listened a lot about AMRs in the morning sessions. What do you see? What are the obstacles and also the challenges in your perspective when we have to talk about AMRs? Also from your perspective, but then of course heading over to Professor Ray.
I mean, the challenges in AMR haven't changed. When we met here in 2017 under the G20, I mean, OneHealth was all about AMR, and nobody cared about zoonotic infections. Now it's all overshadowed by COVID-19, and now it's all viruses and zoonoses, without having solved the AMR issue, of course. That's still there. I mean, back then, I traveled around and said, don't forget zoonotic infections. Now I travel around and say, don't forget AMR. So basically, this is, at the moment, a silent pandemic. Hopefully it will not develop into a less silent pandemic, but chances are pretty good. And this is why I think we need to really continue the efforts that we started in terms of AMR. I mean, creation of new antibiotic therapies, and also this prudent use. This is also now trivial word, but it's so complicated to get this also down to the ground in the different levels. This is something also which is a OneHealth problem in human medicine, in veterinary medicine, and of course everything that's related with the ecosystems as well.
Professor Ray, and then I don't forget you, Sandra. I'm coming back to you in a second. But Professor Ray, how do you look on AMRs? And of course, these questions that were just raised up when we talk about AMRs in science?
Well, AMR was the problem of the way we use antibiotics in industry and in the farm. So there are many things that we discussed about climate change and things to change, and that's another aspect. So the overusing AMRs for different purposes should be controlled. But we don't only have the problem of antimicrobial resistance, we also have the problem of generating new antimicrobials or antivirals, for instance. And that's another whole issue, and there is a very nice statement that Sandra presented. So these antivirals, they should be, especially if possible, as broad as they can be. And we know that there are certain metabolic pathways that all viruses use in cells, for instance, for lipid metabolisms and others, which could be tackled. But we need quite a lot of fundamental research to really understand those, and those should be funded. We should really, I keep insisting on the importance of fundamental research in order to do this. And the other aspect is that these antivirals will work if you administrate them very early during an infection, because after a few, most of the severe cases of disease is after the virus stops replicating and is an overreaction of the immune system. And those are other aspects that really should be known in order to be able to have good measures in addition to vaccines and everything.
Brings us to antivirals. Professor Ciesek, how important is this topic to be prepared for an upcoming pandemic when we have to talk about the antiviral drugs and, of course, the designing of successful antivirals?
Yeah. I think it's very important because if you look for approved antivirals, there's not much on the market. So I think more than 50% or even 70% are against 3 classes of viruses or 3 viruses. It is HIV, HCV, and HPV. There are a lot of other viruses where no antiviral target or no antiviral drug exists. And for preparedness of new pathogens, I think we have at least 3 candidates that may cause a pandemic. These are influenza viruses, coronaviruses, and maybe also flaviviruses. And there we have the chance to now develop antivirals, broad-spectrum antivirals that not only target one of these viruses, for example, SARS-CoV-2, but maybe a whole class, like the coronavirus family, like the flavivirus family. And at least we have different strategies. I think Felix can also mention this. So you can target the virus directly and conserved region of the virus, for example, an enzyme. You can target the host, because the virus always needs host factors in the cell to replicate. These are essential factors for the virus, and if you target the host, then replication can be blocked, and you can target or you can activate the immune system with interference, for example, to make the cell resistant to the infection. These are the 3 strategies, and I think we really need more research on this topic with these viruses, even more viruses, but at least these 3 virus families, to be better prepared and to have antivirals ready if a new pandemic will start.
So 2 different strategies, the direct-acting antivirals and the host targeting agents strategies. Maybe we can go to Professor Ray again. What are pros and cons of these strategies? Can you just quickly give us a wrap-up? I know normally it takes a big scientific paper probably, but
no, but
what are the pros and cons?
In a sense, direct-acting antivirals is targeting the virus. I mean, some viral proteins, there are proteases, polymerases, you need to replicate. The caveat is that very often the virus can develop resistance by changing or are specific to one given virus, whereas those targeting the host can be targeting pathways that the virus does not control and it's in a cell. But you can do this, for instance, the examples that Sandra just mentioned are all viruses that are chronic. HIV, you have it in your life, hepatitis C, so it's different when you challenge an acute infections like influenza or coronaviruses, in which if you give the antiviral very early, it's good. But if you were to have compounds that target the cell, they could become toxic in the long run. But here, if you have a very short window in which you can administer that, you can come up with something very efficient and cure people.
And if you target, for example, the entry factor of the virus, where the virus enters the cell, then you can even avoid infection if you're lucky.
Is that the image that you brought with you?
No.
Or is that another image?
I think it's on the slide, but I think it's not so good presented there.
All right, so we come into that in a minute. Are there any questions from the audience already? I see one hand, another hand. I see young generations here, over there. I have you, yes, I see you. It's great that we have so many generations here, and I think this is important to not just talk about each other, but with each other. So I see two hands, and we do have 2 colleagues with the microphone. I just kindly ask you not to... Oh yeah, you have got the hook microphone, wonderful. Because we're still living in the pandemic times and I don't want to... it's coming already. No, all right, so that's...
Thank you very much.
Thank you. Maybe you quickly introduce yourself and then you have your concrete question.
I'm Ernst Ludwig Winacker, actually also a virologist to some extent, but I was also involved in some management activities. If you talk about OneHealth, you could be inclined to think of the WHO, for example, of the World Health Organization, because it covers the entire world on one hand, and it also covers different disciplines. Now, in your paper here, do you want to create a new WHO, an improved WHO, or something entirely new, which is based on lessons learned from the current pandemics?
Thank you.
That was my question.
Thank you.
And as you know, as you may have heard, I realize that there has been some criticism of WHO.
We heard that. We take your questions to the panel, and I just quickly collect the other question, and then we summarize it up. Is that okay? Wonderful. Where is the gentleman with the other question? Ah, Mr. Peart. Yeah, of course. Sorry. Microphone is coming.
Oh, wow, it's a big one. Thank you. I think this is very important. But one thing I believe that in the prophylactic use of antivirals is going to be very important, particularly for the elderly, for immunocompromised people, where vaccines are actually suboptimal, as long as we haven't solved the problem of senescence in vaccination. So that's kind of, I'm missing that in the whole thing, because that, even for the next wave, I see far more applications for that than actual therapy, where you have to act so early on that it's often not very practical. So it's really important we have better antivirals, not only for COVID. Thank you.
Thank you. Professor Ciesek and Professor Rai, the last question goes clearly, I think, to you, and then we start with OneHealth.
Yeah, I totally agree with you that we need antivirals also for anti-vaxxers that don't want to get the vaccine. That's also a third group. And I think we need both, not only the vaccine, but also antiviral drugs, yes.
Professor Rai, would you add something?
No, yes. Okay. Obviously, prophylactic use of antivirals is extremely important, but I just remind that it's the requirement for no toxicity at all. So they have to be. We still need to be extremely safe in order to spread use of antivirals like that. So,
yeah,
and concerning the question, yeah, I can see Planet Health organization as an extension of the World Health Organization, which...
We're coming to that in a second. Give me one little break before we go into OneHealth.
I just want to add that they then have to be orally, for example, and not intravenously. Then it's a problem if you want to get or take them as a prophylaxis. Yeah.
Every 6 months, you said? Yeah. All right, so then we come to OneHealth, to the OneHealth approach. Professor Mettenleiter, you were mentioning, of course, you were tackling already a little bit of the definition of the OneHealth approach. Now, with this question coming up, is this, something new? Is this a new WHO with some improvements? How would you answer that? And of course, what's your take on that?
I mean, one of the key issues in OneHealth is intersectoral cooperation. And actually, I was very happy to see in mid-March that this quadripartite has actually been formed, which is a cooperation between WHO on the human side, OIE, the World Organization for Animal Health on the animal side, FAO for the agriculture, and UNEP, the United Nations Environmental Program for Environment and Ecosystems. And I think, I mean, this could indeed become a blueprint. I'm not in favor of a super WHO or whatever else as a novel organization. I'm a firm believer in transparent cooperation. We still have some way to go also with these 4 organizations, I'm fully aware. But I think with the quadripartite, we made a step forward. And last year, with the creation under the patronage of these 4 organizations of the OneHealth high-level expert panel, I think, I mean, this is also an important step in this direction. So rather than creating a new super silo, I'm just more in favor of linking the existing silos a lot better.
Professor Ray, you were already trying to answer the question of, of the audience.
I think Thomas said, I agree totally.
But bridging the silos, it sounds easy, but I guess it's a little bit difficult, more difficult than it sounds. So what are the instruments and the methods to be very concrete and sharp and to share a little bit the essence of the bridge?
Indeed, I mean, this sounds quite trivial. It's extremely difficult. Following up on the UK presidency of the G7 last year, these 4 organizations created a OneHealth intelligence scoping study that just looks at the OneHealth projects, programs, intelligence in these 4 organizations. And already this is a major task. This will probably last well into the year 2022. We are still, I mean, they are still working on that, and we are in contact with OLEP. But on the other hand, I mean, as long as they really have the will to cooperate, and this is something that I deduce from the formation of the quadripartite, I think, I mean, we are, at least I'm optimistic that this would work in the future as well. Now, what does that concrete means? It means, for example, that I mean, there is joint support for surveillance systems that are already in existence on the animal side, on the human side, on the environmental side, water, for example, but they are not linked. So, I mean, I think this could be a rather low-hanging fruit to bring these surveillance systems together into one health system. And in this context, I'm indeed in favor of creating a new network, which is not a network that focuses on humans, anthropocentric or animal-centric or nature-centric, but I mean, combining them. And this is one of the goals that we have in OLEP as well.
And do you still stick to the definition of OneHealth? Because earlier we've listened and we've heard it's called also maybe planetary health. So is there room for improvement or room for creativity in naming it, or do you stick to OneHealth?
Actually, there are different definitions. There is OneHealth, there's global health, there's eco-health, there's planetary health. I mean, I may be forgiven, but as a proponent for OneHealth, for me, this is all One Health. It's and the new definition of OneHealth that OLEP developed, and that was unanimously actually welcomed by the 4 partners as well as by the G7 ministers of health. This is an overarching definition, and I would be very happy if you could all agree on one definition to get rid of this Babylonic, I mean, difficulties that we have in definitions of these sub-levels of health. For me, there is no sub-level of health. There is just OneHealth.
You earlier also mentioned OneHealth is, of course, a change of way of living, which means, and then we come to another topic that we touched on earlier, trust. How to build up trust when we talk about OneHealth, and how to build up trust when we talk about being prepared for the next pandemic without spreading too much fear when we are engaging with the civil society. I would just be interested in what's your take on that when we talk again about a little bit of communication, because I think as we just listened to, OneHealth can have different definitions, different names. How do you communicate it clearly that you build up trust and not just fear?
I mean, first of all, communication is one of the 4 C's. So this is central to this OneHealth definition of OLEP. In terms of how should I say? I mean, getting this communication going. I mean, I certainly listened with interest to the discussions this morning that we had. So the trust that is placed actually in science and in scientists, and definitely it's also for us a learning exercise. I mean, how can we transfer this knowledge more towards populations that we would like to target better? And this also requires research. We had the discussion this morning as well. This is something which is underrepresented. It's probably not the most expensive research that needs to be done, but it just needs to be done. And these social aspects are so far quite neglected in terms of what we call pandemic preparedness or prevention, but I mean, for me, they are absolutely essential. Now, I also have to agree, I belong to a generation that did not grow up with Twitter and Instagram and
TikTok, don't forget TikTok.
Or TikTok or whatever. But I mean, exactly, I mean, these are the targets and the influencers that we actually probably need to get on board to bring these messages across.
Absolutely, it's always interesting to, building the bridges, but we need building material for building the bridges, so that's...
But I mean, important is also, if I could just add very briefly, important is also what has been said before, this simple language, so get the message across. We are scientists, so we are used, I mean, to write scientific papers, which are highly complex. I mean, Felix can write papers. They are absolutely fascinating. I don't ask how many of you really understand what's going on there. But I mean, we need to get the message across here in this particular aspect. With Felix's work, it was clear that we need to manipulate, for example, this spike protein of SARS-CoV-2 in a way that it becomes more immunogenic, period. So, I mean, the vaccine is better afterwards. And these are the messages that I think that we need to get across. And this is something that I think we all can just learn.
Professor Ciesek, I mean, you were part of the podcast, very famous podcast here in Germany with the colleague Drosten. And I think you learned it the hard way, the communication, because you were just, falling into the situation that you, from now to tomorrow, you have to explain the world and to the German audience the newest developments of the SARS-CoV pandemic. How do you look you look on the topic when we talk about communication and the right communication of science to a broader audience?
Yeah, I think it's very important. That is what I didn't realize before, to be honest. And it has to be clear and simple. That was already said. And maybe I was thinking about how to continue. Maybe we have to start earlier. We have to go to schools and invest in education in schools, in children, and that they learn, I don't know, how a vaccine works, for example. And I think there's a lot of things to improve in the future.
Professor Mettenleiter.
Yeah, just to come back to a discussion that we had last night at dinner, so we really had good discussions on scientific aspects, where a colleague said, I mean, she had a child in close to the end of school, so in the Oberstufe, and they didn't even talk in their biology lessons on COVID-19, for example. So, I mean, 2 years, this is the major event that's taking place in humankind, and it's not even covered there. So I mean, I think this makes it clear that, I mean, where the gaps actually are.
There is a gap, obviously. Yeah, Professor Rai, you wanted to add on something.
Oh, yes, no. So it's to come back to what Peter Piot was saying this morning. There is research to be funded into how to better communicate these things to the large people, because it's really extremely important. And in particular, scientists, to communicate what we don't know as well, which is as important sometimes of what we know. And the problems we had with the pandemics, for instance, when journalists come to us, so we need to know, and we need to provide an answers to reassure people. That's not what science is about. Science is about knowing something and the incertitudes that we need to discover or find out, and to be able to say we don't know when. And I think there's a whole vision of the way communication has to be done in order to move ahead here.
I mean, it's interesting. I have a feeling that communication is really a hot topic within the science, because it's just not only about the communication towards the civil society or to the media, towards the media, but also, of course, with policymakers. Professor Ciesek, what would you say when we talk about communication, and now we handed over the recommendations today to the policymakers? What's important in that exchange?
It's a difficult question, and I think it's very different because all scientists are different and also the policy makers are different. And from my point of view, I did a lot of studies in Hesse with the ministry, and there it was always good that we have the same goals, I would say, and therefore it was easier to work together. But I think for the policymakers, the most important requirements for me are sustainability. That we don't forget in 1 or 2 years what happened in the pandemic, but that we continue to improve, to work on us, to work on basic research, and also the education has to be continued. And I think this is one of the major works we have to do.
Professor Ray, you're nodding. Do you agree, or do you have to add on something when we talk also about finance, when we talk about policymakers? How do we get the money that we need to be prepared for pandemics?
No, of course. I think science, it's underfunded. I mean, in most of the countries where perhaps some countries are better than others, but at least in the country where I work, there is a lot of, there are many neglected topics on science that we should be invested on, and in particular on viruses, but also in many other aspects of the diseases that are caused. So I think if society can understand that the importance of having a very strong research environment and confidence on the research that is made, we would perhaps be much better prepared in the future.
But what would you say? How is it the most successful way to create a sustainable flow of finance for the pandemic preparedness from your perspective? What is needed?
Well, it is important to commit to funds. For some companies will invest in antivirals, but only if they know that they will be paid back. So we need to figure out ways so that these investments are done, even if there is no profit that will come in an immediate way. So it's an investment in the future. But that has to come from, I believe, from governments and from decisions that are made in advance and which will request to finance better the scientific community.
Mm. Professor Ciesek, you were mentioning it's important to create incentives for the industry sector. Where are we there? Or where would you say? Where is room for improvement? Did we learn the lessons in the pandemic times? That we need to create incentives, and maybe that we need to mobilize private capital to organize a quick development? Or would you say this is really a homework that remains?
I think it's a homework that remains, and maybe you can ask me this question again in 5 years, then I can answer it. But I think this is an important point, because if we have antivirals not ready for phase 2 trials, then we can't use them in a pandemic situation. So there has to be an investment, and I think it's an important point, as also Felix mentioned, and it's hard to say how we will continue, so maybe this is a question for the next years to look back.
I have a look around. Do we have some open questions from you? Oh, wonderful. I see 4 hands. I love it. Very engaging. Great. We start with the second round and then we triple down. Please tell us quickly who you are, and then, of course, your concrete question. Thank you.
So my name is Martin Visbeck. I'm actually an ocean and climate scientist, but I'm very interested in the OneHealth agenda in some ways. And I think I understand it rather well. I read up a bit about it and I agree with almost everything you said. But my question goes a little bit beyond that. 5, 6, 7 years in 2015, we really supported the 2030 Agenda for Sustainable Development, which includes climate change, health, biodiversity, in some ways the future of our planet as from a human-centric point of view. And I wanted to invite you to give us the connection. How does sustainable development connect to the One Health approach? Is the One Health approach a subset of that, focused on certain issues? Is it supporting it in the larger scale? Because I think we have to be a bit careful by generating new narratives all the time and then losing out on the ones that actually are trying to get us ahead. Thank you.
Thank you. Professor Mettenleiter, we start with.
Now, I would say the One Health approach is rooted in the Sustainable Development Goals. And I mean, you find some of them, or many of them actually, in the definition, because I mean, this was one of the starting points that we had for the definition. And this is why we tried to have a definition which is broader than the ones before. The one was basically, I mean, it's human health or human medicine, veterinary medicine, and something that has to do with environment. So this is a lot more specific now. And I also think it's important now we have this linkage to climate change actually in the definition as well, because we are facing similar problems and similar issues, culminating in a change in habits and attitudes. And this is relevant for, I mean, the avoidance of climate change, and it's also relevant for the avoidance of future pandemics. So, I mean, I agree in terms of joining forces. I also agree, I mean, not to create new narratives all the time. That's why I'm so strongly pro this One Health approach, which just by its wording says, I mean, there is this One Health.
Thank you. The next question was just 2 rows behind. Yes, thank you.
Thank you. I'm a medical student here in Berlin, and I have a question about, so I try to pose it as a fundamental question about the role of science in a democracy. Professor Mettenleiter, you talked about, I think, getting the message across. And I think there could also be another opportunity to communicate science, so to really educate people not to become scientists themselves, because of course not everybody can be a scientist in a society, but to really go a little bit further into detail, not to just tell one sentence, but to explain what is going on. And I would like to ask you, what do you think about what could there maybe be the advantage of really educate people to understand what's going on and to decide on the fundament of real knowledge, scientific knowledge, to be critical? And that's also in the context of trust. Like, where is the border between trust and uncritical belief in everybody who seems to be important and knowing something? So I think in a democracy we want people to be critical and to think for themselves. And how do you think we could achieve that? Thank you.
Thank you for your question.
I think for us it's primarily a matter of transparency. So basically making clear what we are doing and why we are doing it in terms of our scientific work. In terms of how to bring the messages across, as I call that, I mean, this is very much dependent, of course, of the target audience. I mean, you have to use a different language if you have, I mean, younger people in front of you than if you have older ones, if you have more specialist ones, if you have the interested public, quote unquote, as it's sometimes mentioned, and they all require, I mean, specific wordings and also, I would say, a specific policy of transferring the messages. I fully agree, but science per se is always based on discussion. Science is always based on critical discussions, and this is basically what we all are doing. I mean, mostly in a friendly way, but of course we do that and try either to verify our hypotheses or to falsify them. And if they are wrong, then I mean we have to start and thinking about the new hypothesis or modification or something like that. And this is what science is all about. And I think this was a major message that was actually brought across also by the podcast. I mean, Christian and Sandra. I mean, scientists are not godlike. They are not infallible. I mean, they are learners, and this is what we are actually doing. So, I mean, what we say today is, I mean, to all what we extent we know is correct today, but it could be wrong tomorrow or the day after, or at least needed to be modified. And these are the messages that we actually need to bring across. And I mean, I feel the more open we are, the more we actually deserve the trust that is actually there.
Mm-hmm. There was another question, I think, yeah, wonderful. Oh, there was a lady in the back, but also the gentleman here. We start with the gentleman.
Hello, I'm Moritz Alkofer. I do physics in Berlin too. And I have a question regarding the One Health approach as well. So you talked about the concept and the organization of it, and I wanted to ask if you could name like some concrete examples where it would be helpful.
I like the ideas of concrete examples. Wonderful question.
I can give you two concrete examples from my background, which is director of a veterinary institute. So we're focusing on that aspect. For example, many of the African countries have now excellent OneHealth programs and plans, national plans, coordinating, for example, the interaction between human medicine, between veterinary medicine, and what they have in the environmental sector. This is a national plan. Just by the way, we don't have a national One Health strategy in Germany yet, hopefully, and this is something that could also be relayed. I also do that. And the second point is looking back into the pandemic. From my point of view, that's why I was stressing it. I mean, I think we need to have the competence and the capacities of all people involved that could help to solve this problem then actually mobilized. And this was also not the case here. Again, talking about veterinarians, it took more than half a year and three amendments of the Infectious Disease Act before veterinarians could just do the testing for SARS-CoV-2. I mean, we are doing multi-species testing all the time, and humans is just one more species. But this was heavily opposed at the beginning, and then we had the same discussion with vaccination later on as well. This is probably a rather tiny bit, but it really exemplifies that we have to change minds, that it is clear the next time that, of course, we need to mobilize everything that's helpful.
Now, absolutely, thank you.
Hi, I'm Isabel Endal. I'm a global health physician, and my question is, what is your idea how we can ensure access to treatment to people at risk globally in the next pandemic? And also, maybe this is rather a political question, but what contribution can science bring to that in terms of science collaborations and so on?
Thank you very much. Herr Mettenleiter, Professor Mettenleiter, I know you've talked a lot, but I would pinpoint the question also to you, the first question, and the second half of the question to the others.
I mean, science is, of course, relevant to get this thing started in the first place. So, I mean, the development of broad-spectrum antivirals is at the moment still a goal. I mean, a dream, basically. We want to have that. I mean, we have scientific knowledge that can be fed into this development. We are not certain that it will actually work in the end. But I mean, these different approaches that Sandra mentioned in terms of targeting the virus, targeting the host as a central requirement, in particular for viruses, I mean, these are aspects that without science wouldn't have been basically on the table at the moment. So this is definitely relevant. In terms of access later on, I mean, this is not a scientific aspect. I mean, this is more than a political aspect. I mean, how can we assure that, I mean, these benefits that we get from the developments are then equally available in the different areas, in different populations, in different societies? And we have talked about this morning as well. This is a challenge, but I mean, again, in COVID-19, at least people started, and politicians started to think about that. I mean, how we can attain more equity the next time.
Professor Ray, when we talk about accessibility of of vaccines, for example, for the most vulnerable people on our planet, and we saw the map earlier this morning that there is an inequality of the distribution of vaccine. How do you look on it? Where do you see the homework for policymakers to actually bridge the gap here?
Well, it is essential. We're seeing all of these new variants that are coming out because of the virus circulates without control in countries that are not vaccinated. So as long as we don't figure out a way to have the whole planet completely vaccinated, we're still going to have that problem. But it goes back to the issue of certain companies have invested huge amounts of money into getting that vaccine ready, and they want to get the payback. So how, and this is a very political issue, and it will have to be taken account. It was done for HIV, for those drugs several years ago, where an agreement was found, and the patents will drop, and there must be some legislation that allow that in case of pandemics, of the global threats like this, there is a limit to what you can limit with the drugs. But also to address to that question, what the science can do, scientists will help creating new therapies. And of course, the idea is to make them as available as possible. The problem is the financement of those particular treatments that can be very expensive to develop. Should the tax money contribute more to that, or how much is to private enterprises? And there are these public partner, PPP.
Public-private partnership.
Public-private partnerships, or that some systems that should be worked out for this type of enterprise.
But when we also raise up the question about collaboration in science, don't you get tired of always debating about, oh, we need to collaborate more? That's not a new thing, is it? Or is it a new thing to discuss about science collaboration or collaboration within the science?
Science is built on collaboration. I collaborate with Thomas. We all need the others. We don't know everything. Each of us provides a little piece of something that makes a big castle in the end. And so science is all about collaboration, I would say. So I don't know.
Professor Ciesek, or straight to the collaboration question?
Just to put it to the ground, I mean, also the development of these vaccines, it didn't occur in the last 12 or 24 months. I mean, there were decades of scientific research before that. And actually, we cooperated with, for example, one of these companies more than 10 years ago and proved that the things work, for example, in a few animal models. So, I mean, the perception that suddenly in February 2020, I mean, the BioNTech boss woke up and had this idea of producing a vaccine. I mean, this was a long-term commitment and a long-term development in science and research.
Yeah, maybe coming back to the question, which is really important, I think, and as a researcher, I don't know what I can really do there, but maybe I mentioned the contracts between industry and universities, and I know that some universities didn't sign contracts with industry if, for example, the drug that was developed was not given to all of other nations, for example, or was specific for, I don't know, one country. And maybe this is one thing that we have to look in this contracts, and that it's fair for all sides, university and industry, but maybe also if a drug will come available, that this is also in this contracts mentioned there. I think that's the only thing I can do as a researcher now.
Are there any more questions from your side, ladies and gentlemen, distinguished guests? Otherwise, we talk about monkeypox now, I would assume. You've got the first case in Frankfurt. That's literally what the media are saying. Professor Ciesek, maybe you can, take us with you in your everyday life. How do you start now as a clinical virologist, and how do you go on with the first case now in Frankfurt? Do you look for old primers?
Yes.
How do you? What's the step one? And you also brought some images. Of the monkeypox.
Yeah, we saw them before. So yes, it was not the first case in Germany, but the first case in Frankfurt. I think it was the 10th in Germany, and this is for a clinical virologist, of course, exciting.
Let's have a look.
I have never seen pox before, and then you go to your freezer and try to find some primers and a PCR, which might be the right. And of course, you can also. It's the last slide.
Yeah, I know. I'm just signing. It's the last slide because this is.
And of course, then you go to the freezer, talk with a team who has ideas, and you look for commercial kits from diagnostics. And this is our pictures. And
so what do we see? Tell us. First case in Frankfurt.
This is monkeypox. No, and we were lucky to have an electron microscopy in our institute. It's a very old institute. The electron microscope is from 1970, I don't know. A really old one, and normally the virology institutes don't have this anymore. And still working, and no one who can use this microscope. And then
so we are not prepared prepared to get more, or are we prepared when we have these?
Yeah, yeah, but I think normally we do PCR testing, and yeah, then we got the first samples and didn't know what will expect us, and then we looked in our electron microscopy and find the virus as shown here. We found it. So on the left side there's 1 monkeypox, on the right side there are 4. And yeah, and then we performed PCR testing with the old primers and new ones, and yeah, diagnosed the first case in Frankfurt, I think a few days before.
And of course, we read a lot in the news, and I think we are the majority of the civil society. They are not virologists. So what's an important message, because today also people from all different silos, bubbles, are watching us today. What is important to communicate when we talk about monkeypox, and when we don't want to spread, of course, some fear, but rather some solutions?
So maybe that it's not from the monkey, and you don't have to cuddle a monkey to get it. No, I think first of all you have to communicate basic knowledge of the virus, like you would communicate to your students in the university. That was I did at Twitter, I think, a week before, and this helps a lot of people to understand yeah, what kind of disease this is, and to learn where it comes from, how to get it, how to treat it. I think these are the information the people want to know.
And the people at the radio stations, Professor Mettenleiter, you just gave some interviews, they also wanted to know, how do we need to be prepared for the monkeypox? So what's the message?
I mean, the message for monkeypox, as for many other infections, is, keep your hygienic standards up. I think, what we did in the last 2 years in the pandemic, we rediscovered hygiene. And I think, this is the most important issue, because, this is not something specific for one agent. This is, overarching. Monkeypox is an interesting case study, because it has been clear or at least discussed since the demise of the Virology virus in the 1980s or early 1980s, that monkeypox could be one of the candidates to fill this gap that Virology actually left. And just in the Democratic Republic of Congo, since early this year, they had more than 1,200 cases. So this is not a rare spillover event. This is not a completely novel virus. This is not something that is absolutely unexpected. So it's something that we know since 1948, where we fortunately have a vaccine and have a therapeutic available, but still, it becomes interesting for us in the society only when it pops up here. And I think this is the awareness that we need to raise. These are the situations wherever they are. This is not restricted to Africa or Asia. This can happen anywhere. But these are the situations that we need to really take seriously. We experience at the moment what happens if we don't take them too seriously.
Professor Ray.
Yeah, so this is, as Thomas just said, there is a vaccine, the same vaccine that was used to eradicate smallpox. It works also against smallpox. But the last doses of vaccine were like 50 years ago to eradicate smallpox, and then people are not vaccinated anymore, and you start seeing it coming up. So now the questions are, could it become more virulent? Could it adapt to better transcription? And many questions, and it's dangerous to let these things propagate as they are now. So even though it doesn't seem to be a very, very bad virus, we need to watch out, because it's just an example of multiple things that could emerge.
Professor Ciesek, when we talk about the first case now in Frankfurt, and of course we earlier talked about how we need to talk also with the policymakers. So how are you in contact and in communication with the policymakers? Do they call you every day and ask for new numbers and new ideas and new details that they need to implement in the regulations? Or what is the most pressing communication?
Hopefully they don't.
Hopefully they don't, yeah.
No, I think it depends on the time. So there were, when I look back at SARS-CoV-2, there were times that they call regularly and ask for help. And But normally you have meetings with different disciplines, with different people, and exchange each other and talk about the virus, what has to be done, what can be improved, for example, but not on a regular basis in the moment. And I think it will start again in fall or in winter, maybe, but in the moment it's quiet.
What do you answer if the question comes up, where are we heading in fall? Do we have an increasing number of COVID-19 numbers? Do we have something to keep in mind already now, when we are now in May, June? Do we forget something? What's coming up in September, October, November?
I'm always looking to Australia, for example, and there we can see that the flu infections rise, and very early there's an increase of flu infections, and I think this might also happen here in Europe, and we have to prepare for this by vaccinating not too late in the year. So normally I always say just take your flu shot in December, for example. I think this will be different this year. I think the COVID-19 cases will increase again. And it strongly depends, and this was what we saw in the talk in the morning, depends on the variant that is circulating and the immune escape, and of course the vaccination status and how long the vaccine will protect us from severe disease. And therefore it's hard to make predictions that are exactly, but I think these are the major factors that we have to keep in mind.
Professor Ray, what do you see in fall?
What do I see? I know I don't have crystal ball, but I expect that SARS-CoV-2 will not go away by magic. It will come. We know already that the infection with the BA1 Omicron does not protect against BA4 and BA5 that are circulating in South Africa now. So we can expect to, if we are lucky, it will become attenuated by itself, but it could. So I have no crystal ball.
And Professor Mettenleiter, last but not least.
No, that's my crystal ball.
Yeah.
I mean, COVID-19 is a respiratory infection, and respiratory infections mostly show seasonality. So I think, I mean, this is a pretty solid prediction that we have for fall. I think it's also rather solid in saying we will see more influenza cases. Basically, influenza completely dropped out in the last 2 years, which was, I mean, at least to me, also a clear aspect of the efficacy of the methods, and in particular the non-pharmaceutical interventions actually that were introduced. So I mean, for a virologist that also is interested in epidemiology, it's absolutely fascinating. We have these waves of influenza, and then we have 2 years absolutely flat. This will probably rise again, and I would agree what Sandra said. I mean, get your flu shot, definitely, and get your flu shot earlier than in previous years.
Thank you very much to Professor Dr. Felix Rey, Director of the Virology Department at the Institut Pasteur in Paris. Thank you very much to Professor Dr. Sandra Ciesek, Director of the Institute of Medical Virology at the University Hospital of Frankfurt and Professor of Medical Virology at the Goethe University in Frankfurt. And last but not least, thank you also to Professor Dr. Thomas Mettenleiter, President of the Friedrich Loeffler Institute and co-chair of the OneHealth High-Level Expert Panel of the FAO. Thank you. This is your round of applause. Thank you.